So this is going to be a look at our intro to functions. So you'll want to print off the notes page that I posted in our Google Classroom and take notes on there and bring that to class on the next day that we're in class together. So functions have a lot of different vocab that we're going to start off with. The first ones are relations versus actual functions. I'm going to move myself right here so you can see it. A relation is a connection between input values and output values. So that could be any sort of rule that you can think of, or it could just be a simple connection. The biggest place we can kind of think of relation in the real world is like a soda machine. You hit the button of the soda you want and it spits out the soda that you selected. Now a function is a very special relation where every input is mapped to exactly one output. So talking about that soda machine, if you were to click on the button and you wanted a Dr. Pepper, every time you click that Dr. Pepper button, you better get Dr. Pepper every single time. So every time you click it, it better bring you right back to this Dr. Pepper. We'd have a problem if you clicked on that Dr. Pepper button and it had been giving you Dr. Pepper, and then just like this one random time it gave you Mountain Dew. This is not a function. We're going to talk about more of that as we go through this entire unit as well. Input values. These are numbers that get plugged into a function. They live in what's called the domain. So the domain is a list of all possible input values. Output values, the results of a number that has been plugged into a function. They live within the range. Where I kind of remember this, domain has the word in to help us go with input value. Independent variable and dependent variable, just like in science, the independent variable is the variable we control or isn't controlled by anything. So we control what happens. So in a science experiment, maybe we talk about what temperature that we're going to set everything to, or how much of one material we're going to put into, like if you're trying to dissolve sugar into water, how much sugar are you going to put into the water? How much water are you going to have? Something that we have control over. The dependent variable is controlled by the independent variable. I'm going to abbreviate that as the IV. So something that is controlled by the IV. Next thing we have are function rules. For our input-output tables. So X is in, Y is out. We're going to plug a number in for X, and we're going to see what we get out for Y. So it could be any number that we want. So let's just start with like the number 0. It's in the X column, so we're going to plug it in for X over here. You're going to find out that anytime you plug a number into a function, you're going to want you want parentheses around it. In this case, the parentheses are a little unnecessary. 0 plus 4 gives us 4. Maybe we plug in -7. We get -7 plus 4. So -7 plus 4 gives us -3. Maybe we plug in 100. This one's pretty simple. We're just going to add 4 to it. We get 104. If you want pi, it becomes pi plus 4. That is our function rule. We take our input, we follow the rule, and we get our output. Ones where it needs a little bit more finesse to it. I just wanted to move this. Guess I'm not really. Oh, there we go. That's what I wanted. Let's move it up here. Okay. Let's say we plug in -3. So y equals 4, parentheses -3 plus, or not plus 5, minus 5. 4 times that -3 gives us -12, minus 5. So we get -17 when we plug in -3. Oh, Jesus. I'm sorry. Maybe we plug in 4. So we get y equals 4, in parentheses, our input of 4 minus 5. So we get 16 minus 5. So y equals 11. Let's just do one more. Let's say 15. So y equals 4 times 15 minus 5. So we get 60 minus 5. And y equals 55. The thing about our input values or input tables is we got to be careful with our actual rule here. So the rule on this one is x squared plus x plus 3. When we plug a number in for x, we have to remember to plug it in for every value of x. So let's say we're going to plug in a -1. This becomes y equals -1 squared plus -1 plus 3. Every value of x gets plugged in for whatever our input value is. This gives us y equals 1 minus 1 plus 3. So it gives us 3. Let's plug in 1 now. To plug in 1, y equals 1 squared plus 1 plus 3. Y equals 1 plus 1 plus 3. So that gives us 5. The thing about these input-output tables and how I'm getting our inputs over here, I am literally just picking. And that's the best part about functions, is we get to pick every single value for x for any function that we want. So if I am unsure about some value for this function, I can plug in a number and figure out what to do with it. It is the most underrated skill in mathematics, is to go the long way and actually plug a number in and see what you get. We're trying to learn all these shortcuts to solve a problem, do all these things, and at the end of the day, we could just plug in a number and see what happens. So if you're unsure, like maybe you don't know what's going to happen when we plug in 10. Well, plug in 10 here. Here's 10 plus 3. The 10 doesn't need parentheses, even though it's not 100% necessary. We get 100 plus 10 plus 3, so we get 113. Last thing that's on that notes page I want you to fill out. We talked about it on Friday for our virtual day, but here's a quick recap. Finding rate of change, remember that it's rise over run. For the rise, up is positive, down is negative. For the run, right is positive, left is negative. Pick any dot that you want. I always start with the leftmost dot. And from here, I have to go down 1, right 3. Since it's down 1, right 3, I have -1 over 3. If you had picked the other way, up 1, left 3, do that in yellow, you'd have 1 over -3, but these two things are exactly the same. They are typically written with the negative out in the middle, not assigned to either number. Finding it in a table like this, still rise over run, but since we don't really have an up or down, left or right feature, Rate of change is our change in y over the change in x. So we're going to see how this right side changes. Likely for us, it's all 4s. We want to make sure that it's in a constant ratio. Doesn't mean that it's going to be the exact same. It just has to be a constant ratio. This other side, we've got to make sure that if these are all the same, these better all be the same. 3, 3, 3. And these are actually negative 4s now that I look at it. So our rate of change is negative 4 over 3. If it happened to be different, say this went to 9, and instead of this one dropping by, and this still dropped by negative 4, and we'd have negative 4 over 2, all this would mean is that this is not a linear function if it's not a consistent ratio all the way through. Even if we had a jump like this, say this side jumped by negative 8, this side would jump a consistent amount. So if this doubled, this would double. And that's what that table would say. If we have two ordered pairs like this, there is a slope formula, m equals, y2 minus y1 all over x2 minus x1. We come over here to our ordered pairs, which are just x's and y's. I'm going to pick one pairing to be 2's, one pairing to be 1's. So this one's going to be 2's. These are going to be the 1's. It does not matter which one is which, just make a choice. But the 2's have to go together, the 1's have to go together. So slope m now says 18 minus 9 all over 7 minus 4. You'll notice that the 18 and the 7 above each other, the 9 and the 4 are above each other. Brings us 9 over 3, which should be simplified to 3 over 1. Another way we could do ordered pairs, which I think can be a little bit simpler, is put them into a table like we just did on the last page. So 4 goes with 9, 7 goes with 18. Again, the order of these points don't matter. I could have the 7 and the 18 on the top. We just have to be careful about some things. And do the same thing. So from here to here, went down 9. From here to here, down 3. Or if you would put them in the other order, up 9, up 3. Either way, these two simplify to that. Same kind of idea, whichever one you find to be simpler. We're going to kind of practice both of them in class. Last but not least, if you have a slope-intercept form equation, slope-intercept form is y equals mx plus b. So the slope is always with x. So in this case, the slope of this equation is negative 3 over 1. If the equation was out of order, that does not matter. The 6 doesn't become the slope just because it's first. The 2/3 is still the slope right here.